they're supposed to be seen here. Okay, so let's go ahead and date it today. So today is December 3rd. And we are taking a look at section 8-3, which is basically quadratics and their graphs. All right, so that's what we're going to be focusing on. Okay, so to begin with, kind of a lot of vocabulary to get you set up so that when a question asks for certain pieces and parts, because they're not just going to give you the parabola and then ask you to graph it, they're going to first probably, especially in my math lab, it's going to walk you through and it's going to ask for a variety of different things. And so there's where your vocab is going to come into play. All right, so let's start with a sketch here. Just a random coordinate plane. And then let's suppose I have a parabola on here. Okay, so we all know what they look like. They're upright in nature, okay, or upside down. They're U-shaped. All right, we've talked about this in the past. That point right there is what's called a vertex of the parabola. All right, it can be either a minimum or a maximum point for the entire graph. In this particular example, because the graph is an upright parabola, this would be considered a minimum point. So let's go ahead and write that down because it's the lowest point of that graph, all right, of the entire graph. So that is a minimum point. All right, now another part that is important and we can calculate is what's called the axis of symmetry. All right, it is always denoted by a dotted line because technically this axis of symmetry is not part of the graph. All right, so that's why it's dotted as opposed to the solid line that we use for the parabola. Same way that we did the horizontal and vertical asymptotes, it's the same thing. This is not a vertical asymptote. All right, it is an axis of symmetry. So it definitely has a different name. And the reason it has a different name is because a parabola, hopefully we know it is symmetric on both the left and right side of the axis of symmetry, okay? And in this upright parabola, let's go ahead and we didn't write the equation. So let's, in function notation, it would be like f of x is equal to an ax squared plus a bx plus a c. I mean, we've wrote this multiple times as standard forms for a quadratic. All right, and with this particular one, the way it is drawn, it is an upright parabola. So then what? That tells us that that a coefficient then, a has to be greater than 0, right? When it's positive, it's upright. When it's negative, it's upside down. All right, so all kind of things that we have talked about in the past, but maybe didn't give a lot of detail about. Now let's go over this. This is, in a way, just like our vertical asymptotes in the sense that I can write the equation of that axis of symmetry. It is an up and down line. So like, let's say maybe, let's say that was going through 3. All right, if that was going through 3, then my axis of symmetry, the equation for the axis of symmetry would be x equals 3 because it's going to be that equation of a vertical line, okay? Just real quickly, I don't want to draw an entire thing and relabel everything, but if we had an upside down parabola, okay, getting worse as I draw them. If it was an upside down one, it's still going to have a vertex, except the vertex is going to be up there. So it is still a vertex. But in this case, all right, because it's an upside down one, that's going to be the highest point of the graph at any point in time, and that's referred to as a maximum point. Okay, so a minimum point when it's upright, the vertex is a maximum point when it is an upside down parabola. All right, and then again, if we were to compare it to this, you'd have f of x equals ax squared plus bx plus c, and that a in this scenario would have to be a negative leading coefficient, so a would have to be less than 0 because it's upside down. All right, so definitely those are kind of things that we've talked about already in the past. All right, and hopefully you're familiar with all that kind of stuff. All right, now let's go ahead and do a little bit more detail about the width, okay? You could possibly, width of a parabola, you could possibly be asked, given like 3 different equations, and then asked, well, put them in order from the widest to the most narrowest, or the narrowest to the most widest. All right, so you can, when given 3, do a little bit of comparison without actually graphing it. You can just think it through, all right? And then you will be able to determine which one would be the widest, which one would be the most narrow, okay? And again, it's all based on that A coefficient, okay? So a couple little things that you could memorize that would help here, okay? The smaller the absolute value of A, and the absolute value is extremely important because we want to take a look at that A coefficient, but we don't want, if there's a negative there, we don't want to deal with that because that negative just tells us whether it's right side or upside down, okay? So the smaller the absolute value of A, the wider the quadratic is, okay? So actually it's just opposite of what you think it's going to be. All right, so the smaller the absolute value of A, the wider the quadratic is. All right, so I can also then write another sentence, which would be just the opposite of that. All right, the larger the absolute value of A, the narrower the quadratic is. Okay, so again, it's just the opposite of what you might think. All right, and basically what they do is they ask a question, they give you three, and then they tell you to put it in order from the most narrowest to the widest, okay? So if I were to do that and just take a look at some, okay, maybe they give me, say, y equals, I don't know, negative 4x squared, and then maybe they give me y equals a 1/4 x squared, and then they give me a y equals an x squared. All right, put this in order, all right, from narrowest to widest, okay? I'm gonna pause long enough to let that person in, and then mark him on the attendance sheet. Okay, there we go. All right, so what I'm gonna do is I'm gonna take each one of these and I'm going to look at the absolute value of my A coefficient. Now, notice that I kept these quadratics really simple. I don't need, to do this example and just to demonstrate how we're going to look at the width of the parabola. I don't need great big long quadratics to deal with this. It's just kind of looking at that width. All right, so I'm going to take that A coefficient. I'm going to take the absolute value of it. Absolute value of negative 4 is a 4. All right, then I'm going to take the absolute value of the A coefficient. And this one, absolute value is 1/4. So that'd be a positive 1/4. And the imaginary 1 that is sitting there, if I take the absolute value of 1, then I get 1, okay? Now, if I take a look at these numbers, all right, that's going to tell me how wide or how narrow the parabola is. Okay, so in this one, 4 is the biggest of these three, all right? 1/4 is the smallest, all right? If this is the biggest one, then basically this one should be pretty narrow. And I'm going to go ahead and draw it upside down because it's negative in my original equation, so I know it's upside down. So this one really should be pretty narrow. All right. This one is a 1/4 positive. It's got to be an upright, so it's got to be the biggest. All right. And then a 1 clearly comes in between 4 and 1/4. So like medium width possibly. And then again, positive, so medium width. Okay. So again, it's not an exact science, all right, but I can clearly tell you that this one is the most narrowest, this one is the widest of these three, and then this one would be somewhere in between. Okay, so again, something else that is something that will probably show up in your My Math Lab type questions. All right, so that pretty much takes care of just like background information, things that you need to know that's going to help you to actually graph these, okay? All right, now we are going to, when we're graphing these, we're going to have a bunch of formulas. So what we're going to do right now is write down all the formulas that's going to help you to organize the things you need to know to be able to graph it. All right, so I am going to write down, we'll start with that standard form again. Okay, that standard form, all right, f of x is equal to ax squared plus bx plus c. Okay, so just definitely, so we've got that to look at. All right, things that they're going to ask you to calculate when trying to graph one of these. Definitely, you're going to want to come up with that axis of symmetry. Okay, so axis of symmetry, and possibly that might even be the actual real first thing that you want to calculate. All right, now the formula for the axis of symmetry is x equals negative b over 2a. All right, with that a and b coming from the a and b coefficients in here. All right, now what people have a tendency to memorize just negative b over 2a. All right, and a lot of people, you know, if you're talking about quadratics, then people can randomly go, oh yeah, negative b over 2a, but then like there's no context. What does it mean? What's it to? All right, the fact that it is x equals is important, and nobody ever really focuses on this x equals part. All right, but that is important because that tells me it's the x coordinate. Okay, it tells me it's the x coordinate of that vertex, because what? The axis of symmetry went right through that vertex. Okay, so this corresponds to the, well, let's actually write that. Let's just not say it. All right, this corresponds to the x coordinate of the vertex. All right, I said it verbally, but now we've actually wrote it down. All right, it corresponds to the x coordinate of the vertex. All right, now formula for the vertex. Okay, well, I can actually put it in a formula form. This right here is the x coordinate. So, and the vertex is what? It's an ordered pair, right? It's an xy, it's an ordered pair. Let's write ordered pair. All right, so that first coordinate is going to be negative b over 2a. All right, anybody that has recently just come out of high school, you're going to remember, what do? You make this calculation, and then what you do, you plug it back into that original function and see what value it spits out. In other words, see what y value comes out. So whatever this number is, that is your x coordinate of your vertex. You take that number, you plug it back in to the original function, and it spits out the y value, or the y value of the ordered pair for the vertex. So now notation wise, all right, if I'm going to plug this into that function, if I'm plugging this into that function, well, I'm going to use function notation, f of negative b over 2a. All right, because we have done this before. What does this tell you to do? It says to take, let's not use that color, let's use this color. It says to take this number right here and plug it into the function. All right, well, what is that number right there? Well, it's the x coordinate, negative b over 2a. So initially, when you first see this notation, it looks a little scary or crazy, but all this is the function notation we've been using all semester long. Okay, in this form right here, we can also calculate the y-intercept because it's the easy one. So the y-intercept. All right, and I'm going to go ahead and write it here like this. Let's see, it's 0c. Okay, so whatever that number is right there, that's going to be the value of the y-intercept. All right, well, and then y. Why is that true? When we're trying to find the y-intercept, we know that x is 0. All right, if this is the y-intercept, this is x, and this is y because it's an ordered pair. The y-intercept, the x has to be 0. So if I were to calculate it by hand, what would I do? I would, to find the y-intercept, I would let x equal 0 and solve. All right, well, what do? If I let x equal 0 and I let x equal 0, those two terms fall out. The only thing's left c. So that's why 0c has to be the y-intercept. Okay, now knowing that this concept, I should have said let x equal 0 and solve. Let's go a little bit more for a y. All right, now if I know that concept, well, then I can also find the x-intercept, all right, by letting, it's just going to be the opposite, letting y equal 0 and then solve for x. Okay, so in other words, if I let y, this is my y, if I let my y equal 0, that's like putting a 0 here, and then I've got a quadratic. Well, what have we been doing? We have been solving those forever. We've solved them by factoring. We've solved them, I think, even by the quadratic formula. Wasn't that last week? Okay, so we've completed the square also. So we've solved them by factoring. We've solved them by the square root property, but can't do that on this one. Completing the square, quadratic formula. Okay, so this one takes a lot of work. Your y-intercept does not. That one should be very, very fast. All right, so this right here is your guide. These are the 4 main things that you're going to have to do when you graph it. They're going to ask you to use these items to graph it. Okay, all right. So let's actually take one of these. On this first one, let's call it a sketch, and I will not use graph paper, okay? So we'll call this first one a sketch, since I'm not going to use graph paper, since you probably do not have graph paper at home. All right, and then the next one I'll graph. So let's say we've got f of x is equal to a 3x squared plus a 12x plus an 8. Okay, so again, in standard form, okay, you're going to go through each of those things that we just talked about. We're going to find the axis of symmetry, then we're going to find the vertex, we'll find that y-intercept, and we'll find that x-intercept as well. All right, so I'm going to label everything. So let's find our axis of symmetry first. A little abbreviation here. So I'm going to do negative. Let's actually start with the x equals, because I told you that was important. So let's keep that there. X equals negative b over 2a. Okay, if I go back up here, my a is going to be 3, my b is going to be 12, my c is going to be. All right, so then it's going to be a matter of, again, let me let this person in. Okay. All right, so let's plug in here a negative 12 over a 2 times a 3. That'll be a negative 12 over 6. So that's going to be a negative 2. Okay, so now I can actually write the equation of this axis of symmetry, x equals negative 2. So I actually know that the axis of symmetry is going to be a vertical line that goes through negative 2. All right, so let's come over here and do our sketch. All right, so negative 2 is right there. So I know the axis of symmetry is going to be right there. Go ahead and label it x equals negative 2 as a vertical line. Okay, so that's the first thing we do. All right, then the second thing that you should do is then move to your vertex. Okay, all right, well, we know the x coordinate. Let's go ahead and write the x coordinate. Start it here. I know the first coordinate is going to be negative 2. Okay, I know it's going to be negative 2. Actually, I probably should not have put a dot there. All right, let's take that dot out. All right. It's going through negative 2, but there doesn't necessarily be a dot right there. All right, let's take this. We know the x coordinate is negative 2. Okay, so what are we supposed to do? Well, to find this y coordinate right there, I'm going to take f of negative 2. I'm going to take this number, I'm going to plug it back into my function. So I'm going to plug it back into this function right here. All right, so you're probably going to use a calculator for this. I'm going to go ahead and crank this out real quick here by hand. It's going to be 3 times a negative 2 squared plus a 12 times a negative 2 plus an 8. Okay, so this is going to be 3 times 4, which is going to be 12. This will be minus 24. This will be plus 8. So negative 12 plus 8, so negative 4. All right, and then once you find that negative 4 right there, all right, that goes back up here as your y coordinate. Okay, so now I know exactly where the vertex is, so I can plot that. So clearly it's going to be negative 2, negative 4. Okay, so negative 2, negative 4. So there's the actual vertex. All right, negative 2, negative 4. Okay, now from there, all right, we can calculate very quickly the y-intercept. All right, because what? We said that it is just automatically that c value. All right, so my y-intercept then is going to be 0, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And this is where sketching you're not necessarily as accurately as it possibly could be. So, but right there is 0, 8. We could label that as 0, 8. Okay, this point right here, we go ahead and label it negative 2, negative 4. Okay, now technically this is symmetrical, right? So if I know 0, 8, 2 to the right and up 8 is a point, then it should be symmetrical. I should have another point right over here, and I had to be able to find that one as well. We're not going to calculate it, but I'm going to find it. All right, so a 2 to the right and then up 8. So 2 to the left and up 8. That has to be another one because it's a reflection. So this point would be negative 4, 8. Okay, but I put it in red because we're not calculating it. I'm doing the fact that it is symmetrical, so I'm getting another point on there. Okay, and then the x-intercept, all right, that's the one that takes a lot of effort and a lot of time. Okay, so what do? We let y equal 0 and then solve for x. So if I take this equation and set it equal to 0, all right, so 3x squared plus 12x plus 8 equals 0. All right, we have solved these over and over and over, and we did it on last Tuesday. All right, this one will not factor. You should always try to factor just in case. All right, this one does not factor. You have to do quadratic formula on this. And since today's lesson really isn't quadratic formula, it's sketching parabolas, what I'm going to do is I'm going to let you, if you want to, work that out on your own using quadratic formula. All right, what you should end up with is like x equals, assuming I did not make a mistake, negative 12 plus or minus the square root of like 48 all over 6. All right, now I think Tuesday when we were doing this, we simplified these radicals. We wrote this in a lot of different forms. Okay, but if I'm trying to sketch or graph the parabolas, I really need the decimal equivalent to this. Okay, I know it's going to be a decimal because square root of 48 doesn't come out even. So I know it's not going to be an integer. All right, so I know it's going to be some type of decimal. But for me to actually be able to graph it, it's going to help tremendously if I have that decimal approximation. So at this point, I would definitely use calculator. All right, and again, if I did not make a mistake, we're going to get x is about equal to negative 0.84, and we're going to get x is about equal to negative 3.15. Okay, so if I wanted to approximate those, I'm going to put these as x-intercepts, okay, would be what? It would be that. I should have wrote here as an ordered pair. Okay, it's going to be x-intercepts, right? So negative 0.8 was roughly right in there. Negative 3.15, there's negative 1, negative 2, negative 3, so a smudgy bit past, all right, which makes sense for my x-intercepts. And then if I were to now connect all of those, okay, I have a very sad looking parabola, but we get the idea. It's an upright parabola. We knew it was upright because it's a positive coefficient. I have some specific points that I know are definitely on the parabola. But again, I'm calling this a sketch because I didn't really use graph paper. If I would have used graph paper and done this, then I would have called this graph as opposed to sketch. But I used that word solely because I did not do this with graph paper. Okay. All right. So this is one that's in standard form. Okay. Now, there's nothing that says they always have to give them to you in standard form. There's a lot of other forms for our quadratics. So let's take a look at something that's not standard form. Okay, so let's go ahead and flip that piece of paper over. It's got some marks on there. All right, so let's now take a look at vertex form. All right, it's just another form for a quadratic. It's vertex form. All right, and we'll go ahead and do it in the function notation type thing. So f of x is equal to a times the quantity x minus h, quantity squared plus k. All right, now it is a very common form. You'll see a lot of quadratics written in this form. All right, and all it really does is actually it speeds up the process if you were going to actually try to sketch this, because the vertex of the parabola jumps right out at you because of the way this is. Okay, now, I don't know in this class if I've said this a lot or not, but when you are given a formula, math formula like the formula for distance or midpoint formula or point slope form or slope intercept form, all those are formulas. And whenever there's a negative in the formula, right, basically the easiest way to remember it is it's going to pull out the opposite number of what you see. All right, if there's a plus in there, you're just going to take that number as you see it. But when there's a negative, you're going to pull out the opposite of what you see. Okay, is how it kind of boils down to. So in this form, my vertex, I don't have to do any math whatsoever to find it. I can just literally look at the equation and come up with it. I can take the opposite of this number, because it's got a negative in front of it, which would then pull out a positive h. All right, and then I pull out this number. It's positive. It's got a plus sign in front of it, so I keep it what it is. And it's going to be hk. So just literally that quick, I can take these two numbers and I can know the vertex. So I don't have to do all that negative b over 2a thing. I don't have to plug it back into the function. I can get the vertex really, really quickly. All right. And then also the axis of symmetry, again, can be really, really quick here. All right, because what is the axis of symmetry? Well, it's the vertical line that goes through the x coordinate of the vertex. And right there's my x coordinate. So the axis of symmetry is x equals h, because it's whatever that number is right there. So that tells me the equation for that vertical axis of symmetry. All right, my y-intercept is going to have to be computed, unfortunately. All right, so here, let's put compute. Why did I say X? I wrote Y. I don't know what I just said. Y-intercept. I want the y-intercept. I'm actually going to have to compute it. All right, and what am I going to do? I plug 0 in for X. So in other words, I'm going to plug 0 into the function. So I'm going to compute f of 0. Okay, x-intercept. All right, we're going to do that just like we did on the last one. We're going to let y equals 0 and solve for x. All right, so no shortcut there. All right, no shortcut here, and a little bit longer here because you got to plug 0 in. Okay, but it's not standard form, so it's not nasty. All right, these two things should be a lot quicker. Okay, now something just for me, what I do, and I teach a lot of vertex form. I can have vertex form on a parabola. You can have vertex form on a cubic equation. So there's just an absolute value equation I can have vertex form. So it comes in handy to have some just general shifting ideas or notions about this. All right, so let's call this shifting hints, okay? Because basically what happens, these are parabolas and they are shifted all around the coordinate plane. I can shift them to the right or to the left. I can shift them up or down. I can do that. And with a parabola, it's going to be that vertex that's what we're going to shift, right? This HK is what we're going to shift around. If this was an absolute value graph, I would still have an HK. I would have the point of the V, okay? So this point here is what gets shifted around. So in this form, f of x equals a x minus, and then I'm going to color code this, h quantity squared. Let's do another one here, and then plus, okay, and we'll put that in blue. All right, this h, you are going to move from the vertex, from the origin, the opposite of what you see, left to right, because it is the x coordinate. The x-axis runs left to right along the graph. All right, you will then move according to the k, the same number that you actually see, and you will move up or down. Okay, now right now that may not make sense, but it will in just a little bit. Okay, because why? Because my k is my y value, and the y value is done up and down on the x and y axis. Okay, all right. Now, with that being said, what I do with my students that are in high school, all right, we do a lot of sketching. So I'm just going to throw this in extra. All right, I get my students so that they can literally sketch these in this form, like in 2 seconds. And it's a sketch because we do not graph, right? So if I give my kids something like f of x is equal to, say, a -3, and then x, let's go plus, just to be a little bit different, 2 squared minus 5. Okay, so I get my high school students so that, and I give them not just parabolas, but everything, absolute value, linear equations, cubic equations, all the different types of equations that we do. All right, I expect them to be able to sketch this like in like 2 seconds. Okay, first of all, we would identify what? That it is clearly going to be a U shape, because that right there tells me U shape. All right, that's a U shape. It's a parabola. All right, then I look at this right here. What's that tell me? That tells me it's going to be upside down, right? All right, and it's 3, absolute value -3 is 3. Okay, so kind of narrow. Okay, but I'm not overly concerned about how wide or how narrow it is, but I can look at that and it's kind of going to be narrow. All right, and then I can real quickly look at this. This right here tells me I'm going to go to the left 2 because it's opposite. All right, this tells me then I'm going to go down 5. Okay, so from the origin, I'm going to go left 2. And then I'm going to go down 5. 1, 2, 3, 4, 5. So I'm going to go left 2, opposite of this one. All right, same, down 5. Go put my dot. I know it's upside down. I know it's relatively narrow. So boom, rough sketch. Now that really, really seriously is a rough sketch. All right, by no means is that graphing. All right, but it is a rough sketch. And honestly, if you're going into higher levels of mathematics like calculus, I just have to roughly know what the shape is and where it's located on the graph, because we do other things in calculus with it. So if I have all my different equations memorized and I can just real quickly pop out a sketch and I know about where it's at on the coordinate plane, all right, then that's really all you need to know, because you're going to do something else with it later. Okay, so this right here is for this purpose. You can then sketch it just really, really quickly. All right, now, unfortunately, in my math lab, you're not going to do this because you're not doing it on paper and pencil. You're doing it on the computer. So you're going to actually be finding the vertex, the axis of symmetry, the y-intercept, the x-intercept, and then actually graphing it. So on this one, again, we got somebody else coming in. So give me 2 seconds here. All right, so on this next example, let's go ahead and graph it. And I'll use graph paper just so we see the difference here. All right, so let's say graph this time. All right, let's say, let's do it in vertex form. Let's go f of x equals -2, x minus 3 quantity squared plus 8. And let's pull over some graph paper here. Okay. All right. Now we're just going to go through and we're going to identify all the little pieces and parts real quickly that we know based on our formulas. All right. So the first thing we need to find is we need to find that vertex. Okay. Now, again, if you remember, this one does opposite left to right. This one does same up or down. All right, based on what I just told you. So in other words, the opposite for the x coordinate, the same for the y coordinate. So really quickly, I can look at this and I can see it's a -3. So that means in my vertex, I'm going to have a +3. And then this is going to be my y coordinate. All right, and it's going to be exactly what I see. I see a +8, so it's going to be a +3. So I know right off the bat, real quick, that my vertex is sitting at 3, 8. Okay, well, so if I do 3, 8, if I do the shifting, I would be doing to the right 3 and up 8, or if I plotted the vertex, I would go 3 to the right and 8 up. So 1, 2, 3, 2, 3, 4, 5, 6, 7, 8. Okay, so right there I know is my vertex. Okay, now just from our A leading coefficient, that's negative, so I know this is going to be upside down. Okay, let's go ahead and put that on there. I know this is going to be upside down. Let's do it like that so I don't have to write it down. Okay, we know that's going to be upside down. Okay, now that I've got my vertex, I can real quickly do my axis of symmetry. The equation for that axis of symmetry, well, since it's an up and down line, it's always going to be x, so it's going to be x equals 3. All right, so let's go ahead and put that on. I'll do that in orange. All right, it's going to go through 3. All right, so there's my axis of symmetry labeled on the graph. If I was doing this, if you were doing this by hand, you would definitely have to put that on there. You'd have to label that as x equals 3. All right, now from there, let's see. Let's go ahead and do the y-intercept next. All right, so on this form, what did we say? We said the y-intercept was take 0, plug it into the function. All right, so in other words, I've got to calculate f of 0. All right, so plugging that in. Okay, so I'm going to have a -2. Parentheses, plug 0 in for that x right there. So 0 minus 3, quantity squared plus 8. Okay, so just a little bit of arithmetic here. This will be a -3. -3 squared is 9. 9 times that -2 is a what? -18 plus the 8. That's going to give me a, let's go ahead and put it here, a -10. So then my y-intercept is 0, -10. Okay, so we'll go ahead and put that on there. Y-intercept 0, -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good, my graph paper just fits. Okay, so right there's my y-intercept. Okay, now to do the x-intercepts, all right, what do? We take 0 and plug it in for y. Okay, so we're plugging it in for this right here. So 0 equals -2 x minus 3 quantity squared plus 8. All right, now solving this, all right, is actually easier than you think, but people try to make this really, really hard. All right, but we know square root property. Okay, so since we know square root property, think that in your mind. You've got this x minus 3 quantity squared. All right, so if I can isolate that by itself on one side of the equation, I take square root of both sides. All right, so the first thing I want to do is what? Let's go ahead and show all the steps here. Let's subtract 8. and subtract 8. Okay, so then that falls out. So then I'm going to have a negative 8 is equal to a negative 2 x minus 3 quantity squared. Okay, now let's get rid of the negative 2 because I can't have that there if I want to use the square root property. So I need to divide both sides by negative 2. Divide by negative 2, that one and that one's going to cross out. All right, negative divided by negative is positive, so 4 is equal to x minus 3 quantity squared. All right, now at this point, so many people want to FOIL this out. All right, there's nothing that says you can't. You could FOIL this out, move the FOIL over, and then, hopefully factor it, if not quadratic formula. But I can also just take the square root of both sides at this point. This is an isolated term, binomial, but still isolated term that has been squared. So I can take square root of both sides. All right. Square root of that side, square and square root goes away. When I square root on this side, I do want to make sure and remember that plus or minus. Okay, so we know that's going to be what? Plus or minus 2 right there. So then I've got plus or minus 2 is equal to x minus 3. All right, I can add 3 to both sides. I'm just going to write it x equals 3 plus or minus 2. And then real quickly, I can calculate those two numbers. 3 plus 2 is 5. 3 minus 2 is 1. Okay, so I've got an x-intercept at 5, 0, and I have an x-intercept at 1, 0. Okay, so they did come out to nice little whole numbers. That's nice. We don't have to estimate them. So 5, 0, 1, 2, 3, 4, 5, and then 1, 0. All right, and if you look, I'm 2 to the right of the axis of symmetry. I'm 2 to the left of the axis of symmetry. So then I am symmetrical right there. Okay, now if I wanted to actually get a symmetrical point here, this is 3 to the left. I could do 3 to the right, 1, 2, 3. All right, and due to the, I know the symmetry, then there we go. All right, I'm on graph paper. I've really graphed this. It's going to go through this point. Both x-intercepts, it's going to come up here, loop, and then come back down. All right, so that is actually graphed because I used graph paper. All right, we found those distinct points on there and then solved it. All right, so the main thing is, like, this stuff will be on your test number 3, but the good thing is you're going to have your notes right there. You're going to have all these formulas. You're going to be able to follow step by step, so it should be pretty good. All right, so I've given you 2 different forms and of graphing these with all the same formulas, your vertex, your axis of symmetry, your x and y intercepts, which are the most common. Okay, now, technically, there's nothing that says you can't use just a good old-fashioned x, y table. All right, that's a lot more work, all right, but it would work. Okay, so technically, my math lab could actually give you an x, y table and ask you to fill it in. All right, so let's take a look at graphing using an XY table. All right, obviously, clearly not the most efficient, I would say not the most efficient way at all. Let's do this with a relatively small equation so that it's easy to do in our head here. So let's say we've got like f of x equals maybe say a 2x squared plus a 3. All right, no middle term, it'll make it easier here. Okay, now if I wanted, I could go ahead and calculate my vertex just so that I kind of know, where has it been shifted in there. So I would probably go ahead and do that vertex, all right, because the vertex is relatively easy, right? That's back to the formula of x equals negative b over 2a. Okay, so let's go back up here and look at this. This clearly is going to be my a value. All right, now I am missing that bx term. I don't have that bx term. So what's that mean? That means b has to be 0. All right, so b has to equal 0 because I'm missing that term. All right, and then that 3 there is the c. Okay, so just because they're missing one of the 3 terms from standard form, all right, you still know standard form exists. All right, you know it's got to have that bx term in there. When it's not there, b has to be 0. Okay, so in other words, if I calculate this out really quick here, what it would be a negative 0, if you can make 0 negative, which not really, but we'll say negative 0. And then all over 2 times 2, it really doesn't even matter what that bottom is because 0 divided by anything is going to be 0, which tells me what? The vertex is going to be right smack dab on the y-axis. Okay, now if I want to then find the y coordinate, okay, what do? Then I take f of 0, I plug it back in, 2 times 0 squared plus 3. All right, this term's going to be 0, so this is going to be 3. So my vertex then ends up being 0, 3. Okay, so that's still, all right. And the only reason that I would even consider going ahead and calculating that is for your XY table. It's going to then help you pick your values. All right, and I'll explain that here in just a minute. Okay, so again, I'm not going to use graph paper. So technically, I suppose we are sketching, but 0, 3. All right, so there's my vertex at 0, 3, and I know it's upright, so I know it's going to be like this. All right, but what does that tell me? That tells me it's going to be symmetrical around that y-axis. All right, so then when I go to make that XY table, all right, which hopefully you did tons in 104, all right, I don't want to just pick like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because what's that going to do? That's only going to give me points on this side of the parabola. I mean, I suppose I could and then just do symmetrical points, but generally, especially, you know, like once you find that vertex, you could pick a couple on this side and a couple on this side. That would let you double check your math. Okay, so I might pick like a -2 and a -1. All right, I already know 0 is 3, and then I could pick a 1, and then I could pick a 2. All right, and then you don't want to necessarily just, if you calculate -2, plug -2 in, that's going to be like -2 squared is 4, times 2 is 8, plus 3 is 11. All right, now I wouldn't just automatically come down here and write 11, because you could catch your mistake. If you made a mistake up here and then you come down here and you plug 2 in, 2 squared is 4, 4 times 2 is 8, plus 3, and then redid the math, you might find a mistake where you had done earlier. All right, plugging in -1, that'll make that a 2, plus 3 is going to give me a 5. Plugging 1 in is still going to give me 5. Okay, so you could generate an XY table like this. These are what? These are X's and Y's, so these are ordered pairs, so -2, 11, which makes sense. That'd be way up here. -1, 5, a little bit over, a little bit up. Okay, so then you could just plot each one of these points. Yeah, but like I said, I have seen on my math lab where they literally had an XY table and they asked you to fill it in and plot the points that way. So we'll go ahead and put some of these on here. There's the -1, 5. Let's go ahead and put the 1, 5 on. All right. I'm just guessing. We'll just call that 11. Okay, so. All right, and then when you're sketching it and you miss it, you just make it really big so that it goes through there. All right, so again, another method, one that I would not necessarily recommend, but it is an option, okay? Now, there is one more thing that I would like to show you. It's kind of like a Trik thing. Again, I don't have my students make an XY table. We do a lot of sketching, but then I also show them a shortcut trick to graphing their parabolas. And as long as for those students that are willing to memorize it, it's really, really nice, actually. Okay. So this one I am going to use graph paper on. Okay. So you're not going to find this in your textbook or anything. This is a me thing. This is something that I do with my students a lot. Okay. So shortcut graphing, and it actually has graphing because we're going to use graph paper here. Shortcut graphing quadratics. Now, it is a trick. It's a process. Once you memorize the trick and learn the trick, then it's actually really, really easy. We're going to do an example in vertex form just because that vertex will spit out just really, really fast, and it's fast. You can do this on standard form. You just have to go through the -b/2a, find the x coordinate, plug it back in to get the y to get that vertex. So it takes a little bit more effort on standard form. However, it still does work. All right, so let's suppose we had f of x is equal to a 3 times x plus 4 quantity squared, and then -5. Okay, so this is clearly that vertex form that we were talking about. All right, and if we do like I usually, for my students in my class, like my high school classes, we don't even write the vertex. I just have them go opposite left or right with this number from the origin, and then they move same up or down with this number. Okay, and then that puts them where that vertex should be. All right, so if I start the origin, this says a +4, so I want to move the opposite left or right that I need to, which means I'm going to go 4 to the left. 1, 2, 3, 4. We'll leave my pencil there. This says -5, so now I've got to do my up and down move I'm going to go exactly what I see. It says down 5, so I'm going to go down 5. 1, 2, 3, 4, 5. All right, and then that's my vertex. All right, so this number, left 4, down 5. Opposite of what you see here, same here. Okay, and then there is the trick to this, or the shortcut is this. You are going to take your A value, and you're going to multiply it by the magic numbers, okay, every time. All right, so, and I'm going to do it 3 times. So the trick part, all right, I'm going to take that A coefficient. Okay, so we'll put A right there so you remember it's A. I'm going to take the 3. All right, I'm going to write it down 3 times because I want 3 different numbers here. All right, then I'm going to multiply it by the magic numbers. And the magic numbers are 1, 3, 5. Those are your magic numbers that you will use on every parabola because it works on every parabola. So I take the A coefficient and I multiply it by 1, 3, 5 every time. And I can keep going. If I had like really huge graph paper, then I would do 1, 3, 5, 7, 9. Okay, I would do all the odd ones if I had really big graph paper. But most of the time, I only need these 2. And because sometimes this is so big that it runs off the graph paper and you can't use that point. Okay, so I'm going to do that calculation. So here I get 3, here I get 9, here I get 15. All right, and then I'm writing all this down now. When you get really, like if you memorize this and you get really good at it, you don't even have to write this stuff down, makes it even faster. Okay, now what I'm going to do, let's write this down so that it's not just me saying it. All right, you always move 1 left to right, right. And then these values, I move up or down. Okay, now up or down as in these are positive numbers, so I'd go up. If they turned out to be negative numbers, I would go down. But why? Because that corresponds to that A leading coefficient. When A is positive, it's an upright parabola, so then these are going to be my Y values going up. If this was negative, I would have negatives on all of these. All of these would be negative, so I would go down because it would be an upside down parabola. Okay, now this is definitely, if you're writing and you've not been watching, now would be a really good time to watch. Okay, so because it's a watch thing, it's not necessarily a write. Okay, so I start at my vertex. I always move. I'm just going to focus on going to the right first and getting my points over here on the right hand side. So I always move to the right or left 1. So I'm going to go to the right. So I'm going to go to the right 1. Watch my cursor. I go to the right 1. Then I'm going to go up 3. 1, 2, 3. I'm going to put my dot. I'm going to leave my pencil right there. I'm going to move to the right 1 because I always go 1 left or right. Then I'm going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, now if I could get 15 on my graph paper, I would move 1 to the right and then I'd go up 15. But see, I'm already off my graph paper, so I don't need this last one. Okay, now if I want to do this again, and I'm going to go to the left side, right? So I'm going to go to the left 1 and then I'm going to go up 3, which makes it symmetrical. And then if I'm going to go 1 to the left and then up 9, it'll make it symmetrical. All right, so right there is the quadratic. Ooh, that's really bad. Is the quadratic graph with the axis of symmetry going right through the middle. Okay, and then like I said, it just took me quite a long time to do this because I was showing you all this. All right, but most of my students can real quickly go, oh, 4, -5. They look at this, they do that in their head. 3 times 1, oh, it's 3. 3 times 3, 9. 3 times 5. And then, I mean, they just do it in their head. They just put them on there. Now, if you were to actually calculate these, do an XY table, and if you plugged in 1, 2, 3, -3 in an XY table for this, it would spit out -2. All right, if you actually plugged in a -2, because that's the coordinate of this one, -2 in an XY table, it would spit out 6, 7, because that's how high it is. These points, when you do this trick right here, these points will always lie on that quadratic every time. All right, it's one of the coolest. This is what makes math cool. Okay, all right, so like I said, this is just a shortcut method and you don't have to memorize this by any means, but it's cool. It's a nice little trick if you've got to graph them. If nothing else, you could use it to check, all right, yourself as to what's going on. after you graph it, because you have to graph it in Math Excel, you can do this real quick, check it, see if it looks right. All right. But honestly, I think that is about all I have to say today, except